everybody, and welcome back to another episode of TALPA Talk, where we give you all the insights and behind the scenes behind everything TALPA. And having with me here today is Saran, who's the expert in this topic. It's really, really nice to have you here with us today, Saran.
Hi, pleasure being here.
Yeah, so can you please tell us more about yourself, your background, what you do here at TALPA?
So I'm Saran Chithran. Of course, I'm a senior machine learning engineer here at TALPA. But basically, I'm from India and I moved to Germany about 6 years back. And first, my master's degree was in geoinformation. And the first job I did was in forestry and AI. So both of these culminated together. And then I moved to TALPA, where it's heavy industry plus ML. So I have been here from TALPA for about 2 years now.
Okay.
Yeah. So I build uptime as a service pipelines, so the machines can speak up before they fail. So this means that I'm involved across the stack by ensuring that the data flows smoothly from training our ML models that detect anomalies to integrating LLMs that turn the machine behavior into clear and understandable insights, and all at scale across industries.
Well, now let's dive into the topic of the day. So what is actually an anomaly in a machine?
That's a good question. So an anomaly is your machine's way of whispering something's not quite right. It could be, it's not a breakdown or it's not even a fault code, but it's something that happens earlier, which is quieter and harder to catch. And so it could be a subtle temperature drift or a slight variation in pressure. But individually for a machine, they may seem harmless, right? But together, as a pattern, they often signal early stages of failure. And that's what our system is trying to catch before it becomes a problem for the machine.
But then why is it important to catch these anomalies, actually?
Unplanned downtime is one of the most expensive and disruptive challenge out there. And that's why early detection matters.
Why?
It's like you spot a tired player in your team before he pulls a muscle. So you just give him a brief recovery and avoid losing this player for the whole season. You don't want that.
How do we detect these anomalies?
All right, so here's where I will not give away any secret recipes. But in simpler terms, we teach our model what normal looks like. Yes, and then we closely monitor for anything that deviates from its normal behavior.
Right.
Yes, it's as simple as that. We collect high-frequency sensor data, and then we train our deep learning models, specifically for our tech folks here, auto-encoder models paired with forecasting heads. And basically what they do is it learns the expected machine behavior over time. And it does it for all different machine types that we train it on and for different operating conditions we train it on. So the model stays reliable there.
Right.
But in terms of the functionality of the model, what it does in near real time, it predicts every minute what is the expected value of these machines, and it compares the value to what's actually happening in the machine. And based on these comparisons, it would say that if it sees a recognizable pattern based on these comparisons, not just a spike of one or two signals, but if it sees a recognizable pattern, that's what our model flags as an anomaly. Yeah. So we avoid any problems from these patterns.
Okay. What makes us different from what's out there in the market?
It doesn't just tell you what went wrong, but it uses our LLM-based root cause analysis, powered by our in-house knowledge base, of course, that's not out there, to explain to you basically why this happened and what you should do next, most importantly, what you should do next to avoid a potential breakdown.
Right.
So it could suggest something like this. So it could suggest the likely components that are being affected by this anomaly, that could get affected by this anomaly, and what are the next recommended actions that you need to take with a detailed report of the of your maintenance plan, and most likely spare parts that you might need as well. Our infrastructure makes sure that the insights land in our app as soon as the data arrives.
We've talked about this already, and how does that actually impact then our customers, for example, in the real world scenario?
That's important because we don't just build something, but we also should make sure that it helps our clients, right? In
obviously.
real world, yes. We have some metrics internally. So our clients have registered an uptime of 98% across their monitored fleet, 98%. and the mean time to repair is down by up to 40%.
Wow.
Yes. And final metric that we track is mean time between failure, which is up by at least 25%.
Wow.
So these are the 3 key metrics that we track. And of course, these aren't just numbers in a sheet, but they are actual proof or solid proof, you could say, that with our system and with TALPA, uptime wins every time. TALPA gives your machine a voice, so they can speak up before they shut down. And it's not just anomaly detection, it's operational foresight that's engineered for minimal downtime and maximum uptime in the real world. Yeah.
Thank you so much, Saran, for all of this. I hope you've enjoyed this episode of TALPA Talk, and we will be bringing you more episodes and more insights about TALPA, and we hope to see you in the next one.